Hi, alright. You know that, or you wouldn't be able to watch this. I've had some people say to me they want to see my green energy product when there's enough light in the garage that they can actually see what I've built. So, you can come over here and I'll give you some background on this. Here's a giant cabinet, whoop-de-doo. Now if you look inside the giant cabinet, hopefully your camera does way better than my phone camera. As you can see, I have 6 batteries. Anyway, I've punched several holes in this cabinet, and by punched I mean drilled, to vent the gases. I also keep the doors open, although I could shut them because I have several vent holes. But the batteries are all positive to positive, so you'll have basically 6 positives hooked together, 6 negatives hooked together. The wires, I actually drilled holes in the shelves, ran the wires right through the shelves. Now, coming in to charge these batteries, as you see here, I have 3 charge controllers. You notice, like right now I'm at 13.4. Well, of course, the sun's out. Now these are on. I just have the display shut off, but they're there. I just have the display shut off so I don't have to waste the power. And I'm sure you're saying, well, Eric, the sun goes down. Gosh, then what? Well, let me show you. Over here, if you look down here on the ground, see how thick this cable here is? This is for a turbine. It runs in. This is a turbine charge controller. If you notice, there's 3 wires because my turbine is actually AC power. The reason I come up with an AC turbine is because there's less moving parts. In 5 years I might have a bearing wear out, but not much. This is my amp meter for my turbine. Right now the turbine really doesn't need to turn because my batteries are fully charged. This is a 1000-watt power inverter. This is what converts the batteries to usable AC power in the house. So if you was to follow these 2 wires here, and you're not going to, they would just basically go in there, one hooked to positive, one hooked to negative. This cord here, if you was to follow it forever, and I don't want to because we've done that in like 10 videos, goes through my wall, comes out in my living room. In an emergency, this can run a fan, a TV, a light, phone chargers, whatever you want, living room stuff. Most likely it'll run an electric blanket and a little TV because that would be the stuff you would want if the power was out. Also on here, I don't know if you notice or not, there's actually slots where you could actually plug your cell phone right in here and charge it right from here. You don't even have to run a cord in the house. Now over here, this is the fun side. Hopefully the camera, the light on the camera, it'll grab it. This is a power inverter. If you come over to the other side and look, now that there's some light in here, you will see there's some LEDs. You notice the LEDs are running right now. What that means is I'm taking most of the power from the solar panels that I have on the roof and I'm inverting it here. I send it here. Now this cord here, if you was to follow this forever, it actually goes to that wall over there. It just plugs in. I have it plugged into an outlet, so I'm feeding this power back to DP&L basically. This up here is a charge controller for my big solar panels. These switches here, this is something I come up with. The solar panels are actually going to these switches and going here and skipping this charge controller. Well, if the power goes out, DP&L is not going to want my power anymore. This thing is going to shut off. It has island control. That way I don't fry a line worker out there somewhere. This will automatically shut off. However, I can throw these 2 switches. What this is the negative and the positive because the solar panels are DC power already. Now you notice this LED up here is moving. What that's doing now is that's charging batteries. That is something you would need if the power is out, because most people have solar panels and when the power is out, the solar panels on their roof are a decoration. This is a 2000-watt power inverter. See right here's where I turn it on. As you see, I've got just about as much juice as I can handle. It's like fully maxed. If you was to follow this forever, it goes through the wall. It comes out as outlets in my house. I call them my green outlets. I have one by my refrigerator, one by my washer in my laundry room. If the power's out, this can run my refrigerator. In fact, I do laundry just about every day on green energy without using the solar panels because I also have the turbine. All day the turbine charges the batteries. I come home 4 o'clock in the morning, I turn this on, I do a load of laundry without even involving them. But anyway, with those on, now look at the juice in here. As you see, I really didn't need to turn those on in here because now I've got like a crazy amount of juice. So I will put those back. Now you'll notice over here on the power inverter it is now green and flashing again, which means I'm saying, here you go DP&L, I don't need your power, but here, have some of mine. And what that also means is if I send them more than I use, it means my meter spins backwards and it'll take money off my bill. Believe me, by the end of the day, I will have used more than I sent, but not by a hell of a lot. Every month my power bill just keeps getting lower and lower. So conceptually, that's the design. Now you've seen it in the light. You're welcome.